Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hello and welcome to another episode of the GOTO Book Club. In this episode, we're going to cover Release It, the second edition by Michael Nygard. I'm Trisha Gee. I'm a Java champion, a developer advocate, and I'm going to be asking Mike all about his book. Mike, please introduce yourself.
Hi, I'm Mike Nygard. I've been a developer and architect and now technology leader for more years than I really care to admit. I was one of the early developers to go into operations and learned some hard experiences from being woken up at 3 and 4 in the morning for weeks on end, and tried to sort of bring back my experience from there, because when I went into operations, I thought it would be about fans failing and replacing disk drives. And that was the tiny minority of problems we resolved. It was all software problems. And so that's what motivated me to write the book. And I've since spent a lot of time traveling around the world to conferences where we met and teaching people how to make software that survives production.
Which kind of preempts a little bit my next question, which is, can you give us a quick overview of the book? What does it cover and who is it for?
Well, the primary audience is the professional software developer or architect. It covers a lot of the topics that generally weren't addressed in software design courses or in training that you would find, because those would always have these very short examples, and they would say things like, error handling is omitted for clarity. And then you read real software that's been around for a while, and it's like 3/4 of the code is about error handling and recovering from weird states. So there was this whole big space that just, it wasn't being talked about. And kind of at the same time, we were moving into larger scale systems, web systems that have to be on all the time. You don't get a maintenance window. You may have very large volumes of people arriving all at once. So it had more demanding characteristics, and people weren't really being taught how to design for that. So that was the primary emphasis, was kind of filling that gap.
Yeah, I mean, one of the things that, like you said a bit earlier on, one of the themes which keeps coming up in the book is they're being woken up at 4 o'clock in the morning with some sort of error. And you're right, when I was a developer in the noughties, that never happened to developers because that was an ops problem. And we just didn't feel that pain of something that we'd written that was causing production problems and causing the ops folks to have to figure out what on earth we'd written in our applications. The first edition is a classic in my mind, and it came at just the right time. It sort of preempted the DevOps thing, and in my mind kind of was part of the input to the movement towards DevOps, where developers are encouraged to start thinking about how do you get your code into production, and what is the impact, what's the difference between running in production and running it on your machine. So the first edition is now a little while back. What has changed in the book since that first edition? What's new in the second edition?
When I started contemplating the second edition, I started making a list of what had changed in terms of infrastructure and architecture and the market. And it was like all of smartphones and mobile apps, basically all of the cloud. I think in the first edition, I had maybe a page about, if you're going to the cloud, then a bunch of these rules change. And by the time I sat down for the second edition, it was sort of like cloud was almost the default or the de facto standard. We had the entire movement around open source monitoring and management tools. When I wrote the first book, if you wanted monitoring in production, you went to HP and signed a check with a lot of zeros on it to acquire OpenView, or some similar licensed package. And then by the time we looked at the second one, there's this embarrassment of riches around monitoring tools. And the question is, which ones do you plug together rather than, are there any? So an enormous amount had changed. Some things hadn't changed. And that was actually gratifying that, there were some things that stood the test of time. A lot of the material around stability and distributed systems absolutely still remains true. But for example, there was a large section on capacity management that both was too specific to physical hardware and also needed to be generalized to take on physical environments, cloud environments, auto-scaling environments. And there's sort of been this shift in the cloud world away from capacity management to cost management. Because you can always get the capacity, and it's really about how much do you want to burn. So I removed that section, changed it completely, put in a whole new section around structuring cloud-based systems, removed a large section around the what I had termed the Ops DB in the first edition, because people had actually gone and built the things. So I didn't really need to talk about why you should have one. So it needed a lot of updating. I also added an extensive amount about virtualization and cloud environments, plus a couple of new stability anti-patterns and patterns that had been discovered in the time since the first edition.
You just said a whole bunch of things that I want to explore more. One of the things was visibility. Yeah, so I went back and had a quick look at the first edition, and I could see there was a certain amount of there were a certain number of pages devoted to explaining why you need visibility and monitoring, and this whole thing about this seems to be important. And it's really funny to read the first edition now, because you're like, well, duh, of course you need all of that stuff. And the second edition is much more like, yes, of course you need all of that. Like, and this is what you can do, and this is what it gives you, which I thought was, really, really valuable and much more aligned with where a lot of applications are these days, I think.
Well, there's a meme on the TV Tropes site that says Seinfeld isn't funny. And what it's referring to is, if you watch Seinfeld now, maybe for the first time, you'll recognize all of the jokes the instant they're being set up. That's because they've been repeated so many times and imitated so many times that they now are just sort of common expectation. There's nothing surprising about it. When Seinfeld was on at first, they were new, fresh, surprising, and funny. So yeah, all the part about observability, that's sort of like, it was new at the time, but has now become kind of accepted conventional wisdom, which is great. I'm happy for that.
Yeah, for sure. You don't have to devote pages trying to sell developers on this is an important thing. You're like, look, let's just assume that you're going to do this. So that was good. And I also similarly, I thought what was quite interesting was when you're talking about not just the auto scaling side of stuff, but like virtualization and things, the fact that you have to be quite careful about the terminology and define those terms, because before in the first edition you're able to talk about a server, and everyone has in their head like a server and a data center, and now you're like, what does that mean?
Right. It's no longer a pizza box with blinking lights.
Right, or it might be.
There's a really fascinating thing happening in the large scale data centers where virtualization is now moving a layer below the CPU. So it used to be that you'd run the hypervisor on the CPU, it would intercept all of your hardware operations. Now, especially in AWS and Azure, a lot of those things have been moved out onto the PCI bus, where your CPU is just running a regular operating system, thinks it's talking to local storage, but it's actually being intercepted by a smart device that turns it into a remote network call. So server now is like, yeah, you have your CPU that you're programming, but it's surrounded by 100 other cores that are all pretending that the CPU is in the same kind of server architecture it used to be. So the picture just continues to get more evolved and more complicated.
Right, for sure. I mean, I think that was, to me, that was one of the takeaway points of certainly later on in the book where you're explaining the terminology. You're like, as developers, we have to worry about so much more than we used to have to worry about. And it's a good thing to think about production, but we also have to understand, like get a bit closer to the hardware than we used to get. And then we're not even that close to the hardware because there's all these different layers between us. And I, because you early on in the book, you're talking a bit about how TCP works. And, it's important for us to understand what's actually going on. Otherwise, we can't anticipate potential problems in production if we don't know what's going on. And things have got so much more complicated these days.
For sure. And not only can we not anticipate the problems, when the problems do occur, you sometimes have to peel back a layer of abstraction to understand what the actual problem is. And so, diagnosis and problem solving usually requires awareness and visibility at a level below where you have caused the problem.
I liked all the stories that you had in the book, all the case studies and things. I like the way that you said things like the things like the CPU usage is low, but nothing's happening. And that told me that there was something waiting on something. And that's where your experience really shows, because other developers could look at the system and all this visibility and monitoring and observability that we have and be like, there's no errors and it's not working. Like, what do I do? But that you really clearly explain, under these circumstances, my suspicion was connection pooling or garbage collection, or because I've seen this sort of thing before. And I thought that using stories and then having the anti-patterns and then the what to do about it was like a really helpful way to teach developers, like, what are the problems, what's causing those problems, and what you can do to prevent those things in future. Well,
thank you. Certainly people learn from stories. Humans are storytelling creatures. It's one way of transferring experience without having to suffer through it. But you also mentioned that notion of seeing an observation and then forming a hypothesis about what that observation indicates. And that's a step that really requires a mental model of the system underneath in order to be able to create a plausible hypothesis. And of course, then you go from observation to hypothesis, and then you say, if this hypothesis is true, what else would I see? Or what would I observe that would disprove this hypothesis? So you kind of go from observation to model to observation. And the model is the crucial step. Otherwise, you'll just be overwhelmed with all the data and the graphs and the flowing numbers and, seeing the matrix characters dribbling down your screen and so on.
Yeah. And one of the things that really hit me early on in the book, when you're talking about how, I can't remember the terminology you used. I've already forgotten. Like how, like a small failure can like lead to the cracks in the system, which can end up like bringing everything down. Or to begin with, you see everything coming down. It's very difficult to trace it back without experience, without reading a book like yours. Difficult to trace it back to that one line of code where you forgot to close your file handles or whatever.
Yeah, it can be. It can be, especially because the initial fault can be quite small. But then once it begins to create this snowball effect and you have the cascading failures, so many other things begin to report problems that they can absolutely drown out, the one little, the true cause that was, maybe one line in your log file. And then you have thousands and thousands of log reports about, services not responding.
And you know perfectly well, and you say this in the book as well, that as soon as an app becomes unresponsive, particularly if it's a mobile app or a web app that's got like real human beings on the other end rather than like an intranet type app, people are hitting refresh. And you know for a fact that's just going to make things worse. And one of the things that you mention a bunch in the book as well is that QA does not replicate these types of situations, because a tester or an automated test is not going to hit refresh 27 times after something goes wrong. And you don't see those sorts of things in QA.
Yeah, it's true. In fact, just recently, I was investigating a defect. This one wasn't an outage, but it was a defect that occurred with multiple users interacting with their mobile apps simultaneously. And there was some information leakage from one user's session to another user's session. And as we dug into, kind of the whole tree of causes that contributed to this, one of the things we observed was that there was QA, but because it was a mobile app, the QA was still manual at this company. And they were testing against an environment that had paired servers for HA testing. But they never had enough testers using it simultaneously to have, even a 1% chance of two requests being on the same node at the same time. So, either they would come one after the other on the same node, or they'd be load balanced across nodes. And so there's a statistical element that's hard to produce in QA unless you devote a lot of resources to it.
Right. And my takeaway from that was not that we shouldn't do QA, because I could see some developers being like, or business, if you like, going, oh, testing is expensive and it doesn't catch these type of defects. It's like, no. It's like you still need the QA that we're used to seeing and the automated tests and, if possible, beef up to be a bit more like production. The fact is that the sorts of problems you see in production, you will probably only ever see in production, and you have to anticipate them and not just throw away all of your other efforts and go, oh, it's useless, right?
Oh, for sure. I would even say, with regards to QA, my response would not be to say we need to stop doing QA. It would actually be to say we need to do more different types of QA. So we got a long ways for a long time in the industry with people kind of clicking around GUIs and manual things. We scripted that, automated it. That helped make it more repeatable, more scalable. We moved to unit testing, which I fully endorse, but maybe we went too far and tried to do everything through unit testing. I'm now also a big fan of property-based or generative testing. I certainly like load testing. I do some model-driven testing where I have kind of a Markov model of how users interact with the system. And so that can generate endless streams of really odd traffic that ordinary human testers might not think to produce on their own. Or you wouldn't see it written in a test plan because it looks kind of wacky to have in a test plan, refreshing the page 27 times. But when you use more different types of QA, each one is good at finding a certain class of problems. And the first time you do one of these kinds of testing, you'll find a bunch of problems. Pushing that style of testing farther and farther and farther creates diminishing returns. And so there comes a point where you're better off stopping with one kind of testing and adding another kind.
Right. I saw you mention load testing a few times in the book as well. And even obviously having load testing is a good thing. But even the sort of automated load testing that we might naively implement to begin with isn't necessarily the same as what users might do. I was taken by what you said about some of these sessions that kind of like log back on again after like 15 minutes. And you'll never see that sort of thing in an automated test because it runs for 5 minutes, 10 minutes, whatever.
Yeah, in a way, even the automated load tests are too predictable.
Yeah. I think that's the main thing for me that I took out of the book is that, and you know, I've been writing software for 20 years and seen a lot of different things, but there's still users are going to do weird stuff. And as our applications get way more complicated and we're running stuff on the cloud and we don't know where the servers are and we don't know how it's scaled out, and we're talking about social networks. When you did the first edition of the book, you probably had no idea that a piece of software was going to service like a million users. You know, it's just
no.
And things are only going to get worse from here as far as I'm concerned.
Well, I think there's even another shift that's well underway in most organizations, which is to create internal platforms where the users are now other pieces of software inside the company. And it's a premise of an internal platform that new use cases and new services can show up and start consuming the platform kind of without notice, without permission, without having to tell you as the provider of the platform that they're going to start using it. And so when we think about users being kind of random and unpredictable and doing clever things with our software, we now also have to think about the internal software using our platforms in unpredictable or unexpected ways.
I hadn't even thought about that because, when I worked in the world of developing intranet applications, you could literally physically meet your users. You would go and see the 12 people using your software. It didn't occur to me that there might be internal systems using your internal system doing I don't know what. One of the things I read just gave me terrible flashbacks. The deployment case study where you had 20 people sat around a conference table. You'd had the go, no go meetings and, you start the whole thing at 10 o'clock at night and the business are going to wake up at 1 o'clock in the morning to do UAT. And I had terrible flashbacks because I've definitely worked in more than one environment that does that. My question was, do you still see organizations doing that kind of manual deployment process, which, as you costed out in the book, is ridiculously expensive and very painful?
It's not as far in the past as you might like. Just recently, I did observe a cutover process for an airline moving from one passenger support system to another passenger support system. This happens all in one night with airplanes in the air, airports in operations. So literally as a gate agent, you may be there checking people in for one flight using one system. And then by the time you're checking people in for the next flight, you're on the new system. It's a massive, massive change. You can think about, how widely distributed airports and baggage claims and terminals are, all the different states that a flight can be in, all the edge cases and the unhappy paths that travelers can experience, and to have that all happen, overnight, while there are actually planes in the air that took off using one PSS and landed using another PSS. So in an event like that, yeah, there's absolutely a war room. In fact, for this one, there were war rooms at multiple companies in multiple countries, making sure that it all went off. And to this company's credit, it did work. There were, there was a punch list of minor things. There were corrections happening in the middle of the night, but all of the airline's operations continued. And there were, several hundred people involved in that particular cutover. Now, I will say that is not a routine event. That is not the quarterly deployment process. But there are still, quarterly deployment processes at companies that have not automated, and there's a sort of a vicious cycle that keeps them stuck in this mode. They'll do the big overnight thing with the playbook, and they've customized the playbook every time. And so not everything works every time. It requires human intervention to recover, which reinforces the idea that we can't automate this because it requires humans to do things, every time. Where if they started from the premise that said, we can automate this by standardizing it, and the value of automation is enough to make it worth the cost of standardizing, then they would get out of this trap. But it's sadly common still.
Yeah. I've worked those sorts of organizations where the release is so painful and so time consuming that they do it rarely, and therefore there's no need to automate it. And so you end up in this loop. But my assumption was that now we have continuous delivery and we have your book out there and we have DevOps and automation has got so much better and we have cloud. In theory, organizations are taking advantage of at least some of those things to move closer to an automated deployment process, perhaps. Or maybe it's just such a big change that they can't get over the hump.
I think it's like many of these sort of diffusion curve problems. Many organizations are well along the transition. Many of them have made that transition completely. But the mass of legacy software out there is so vast. And some of it is in this state that sort of like terminal life support. They can't quite afford to shut it down and replace it. but they can't quite afford to really modernize it. And so it limps along, sucking people's lives away.
I had another question on that area, which is, so organizations which are following more of a continuous delivery type thing and have taken advantage of DevOps, who read your first edition of the book, they must be facing their own challenges, I assume, in terms of deployment, getting it into production, making that work. Like, what sorts of things have you seen in that space?
This is actually one of the subjects I have a lot of fun with, because as we have introduced more automation to do these jobs for us, the automation itself has created new ways to disrupt and break our systems. So I have a couple of examples in the second edition about kind of automation gone wrong. One of them comes from Reddit, that had a very serious outage when they were doing a migration of one of their configuration systems, Zookeeper, from one cluster to another cluster. They had an auto scaling service that used that configuration to determine what should be running out in the environment. Because they were going to be moving clusters, they deactivated the auto scaling service. Makes perfect sense. They didn't want it looking at partial or incomplete data. Midway through their migration, a different configuration management service saw that the auto scaling service was down and said, oh, auto scaling should be up. So that piece of automation turned on the auto scaling service, which looked at the incomplete data and said, oh, apparently all of Reddit runs on 3 servers, and it shut down thousands of nodes. And it did it very, very quickly. It took a long time for Reddit to recover from that, because they had to actually fix the auto scaling, bring back all the nodes, warm up all the caches. So it was quite a large recovery effort, and it happened because these different pieces of automation were interacting with each other indirectly through the environment. So this is kind of a force multiplier effect, where the power of automation is it can do a lot of things very quickly, and the risk of automation is that it can do a lot of things very quickly.
So I guess the challenge then is to really understand the environment that you're trying to deploy into, and anticipate what could go wrong when you don't really know what's happening or what could go wrong.
Well, that sounds a little bit impossible, right? Right. That's in the unknown unknowns category. But there are things you can do to give yourself a fighting chance. One of them is certain actions are safer than other actions. So if I need to bring up 10% more nodes than I've got, that's a relatively safe action, subject to budgetary limits and thresholds and limiting the burn rate. If I decide to shut off 50% of the nodes that are running, that may be an unsafe action. And so one of the things I recommend is actually building into your automation some degree of understanding about what's a safe action and what's an unsafe action. And just slow down the unsafe actions a little bit to give the intelligent elements in this socio-technical system an opportunity to see that something is not going right and intervene. If any human saw that the autoscaler said, shutting down 100,000 nodes, 50% complete, they go, oh my God, stop. And they'd be able to prevent the disaster. But the decision was taken automatically. The action was done very quickly. There were no sort of guardrails or limits that said never shut down more than 10% at a time. Don't do shutdowns more than once every 5 minutes or something like that. So in a way, we have to create some notion of inertia or momentum, or just some friction to slow down those unsafe actions.
Right. As you said, the automation, the speed of automation is the problem, really, and the lack of intelligence as well. Like brute force is not usually the right answer. I looked up when the first edition came out, and it was basically about the same time that people started talking about DevOps. And I'm guessing that DevOps was just not really a thing when the first edition came out. So I was kind of interested in my mind, the first edition very much fed into, was one of the inputs into the DevOps movement, and the fact that developers need to care a lot more about not just like writing lines of code on their laptop, but how it really works into production. So I was interested in how, given that the first edition fed into the DevOps movement, how much did the sort of DevOps movement feed back into the second edition, and sort of how has your thinking changed, and what's happened there?
Well, speaking of feedback loops, yes, you're exactly right. That did happen. Both of those influences were definitely there. When you look at the second edition, I think you'll see that there's sort of more of a notion of an ongoing process of adaptation and change. And so it's less about kind of big releases, ironic given the title of the book, but it's sort of about continual pathfinding. The back section of the new edition, and I know people only read the first half or 2/3 of most tech books, but the last half talks about some of the ways of thinking about architectural change in a continuous way, and thinking about programmatic change in a continuous way. And that's very much driven by observations from DevOps, where, for example, in the DevOps world, we talk about very significant architectural changes driven by operational issues. I think it was probably John Allspaw, but it might be somebody else that I heard this story from. But imagine a large MySQL database or Oracle database, and operations kind of coming back and saying, look, there's really just no way to do these kind of continual zero downtime deployments, because every time we make a schema change, we have to re-index these massive tables of users. And as we're re-indexing, we can't do any transactions on it. So you're going to observe downtime whether you want it or not. That's an operational consideration, but it motivated a move to a different database technology and a different architecture, where that table was partitioned and sharded across many different instances, precisely so that they could do the zero downtime deployments. And so when you think about that kind of feedback loop happening on an ongoing basis, that's kind of what the last section of the new edition is about.
Right. And I like the way that whole thing feeds into, a lot of the trends over the last sort of 10 years have been taking what Agile started in terms of like iterations and fast feedback, and sort of applying that to pretty much everything, and evolutionary architecture and all of that kind of thing. It's all about observing and feeding back and making changes and iterating over that.
In the DevOps community, that's now even being extended to internal audit and IT risk management. That same notion of continual feedback and incremental change. So it's spreading the joy of Agile everywhere.
Good. Spreading the joy. My experience of risk management is that it's not very iterative at all, so I'm really pleased to hear that. One last question, because I think we're going to wrap up soon. It was a slightly more, less book-focused question and a more you-focused question. What's changed with you since the first edition was released? What have you been working on, and how did that impact this book, if you want to tie it back to the book?
Well, even the second edition is a little bit aged now. So the second edition was 2018. A few things have changed in the world since 2018. So as for myself, I'm now working for a Brazilian financial services fintech startup called Nubank, with operations in Brazil, Colombia, and Mexico. And in particular, I'm responsible for the data analytics platform. And this is an area that I think DevOps has largely ignored or bypassed. Still very much centralized operations, throw it over the wall, run in a big batch. So I'm keenly interested in how we can take the same principles and practices and bring them into the data world, where, sometimes just running a join on this 10 billion row table takes several minutes. Maybe even, you're doing a calculation that takes an hour or two. So how do you get fast feedback in an environment where once you run it and it breaks, your cycle time there is measured in hours or days? So it's going to be an interesting set of challenges.
I'm looking forward to the third edition. Thank you. I want to give you one last chance. If there's anything else you want to comment on about the book or anything else you want to say.
The largest thing I would say is very often we look at the challenges of adapting to the new world, cloud native continuous deployment. And we say, we can't do this because XYZ. I would like people to invert their thinking around that and say, it's valuable to do this. And in order to do it, X, Y, and Z must be true. And it seems like a little, linguistic inversion and maybe just playing games with words, but actually expressing things in terms of prerequisites rather than obstacles, it does have a pretty large change in how we approach things. And so that would be my encouragement. If you're struggling to get to this more continuous, feedback-driven, incremental style of work, start enumerating the things which must be true in order for that to be part of your world.
I like that. I like that because it's useful, but it's more like positive and more proactive. Like we need to do this, this, and this, and then we can get to where we want to be.
Exactly so.
Great. Well, thank you very much, Mike. I hope lots of people buy your book because it is extremely helpful. I love the way it's been updated to encompass a whole bunch of more modern patterns of developing applications, and I think everyone should read it. Thank you.
It's been my pleasure.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.